Lesson 7, those of you that are really observant may notice we went from lesson 5 to lesson 7. It is because I can't count. Go figure. It says, using the following algebra tile diagram. We are reviewing these algebra tiles. I've already gone on a big rant, Kenzie, about how for me as a non-visual learner, I don't find them hugely useful, but some kids do. They are often going to ask you a question on the provincial exam, kind of to interpret some kind of a picture. So I'm practicing this. It says, using the following algebra tile diagram, write the polynomial expression that's represented. What did one of these things mean? Okay, so this is going to be an x squared. What do these things mean? What were those representative of? X is how many? So we would say plus 6x's. And what do these things mean? They're ones, and how many of them are there? X squared plus 6x plus 6. You know what? I just realized there's a typo in my diagram. So can all of you right now, we're going to add one more square and one more little square. We're going to, instead of plus 6, we're going to make it a plus 8. This is what happens when I cut and paste and forget to cut and paste properly. Okay? That way, Halen, it matches this diagram that we're about to look at. Because I'm pretty sure this diagram has 8 little tiny squares if you do the math. If you took these squares, you can actually rearrange them into a perfect rectangle. You put the x squared in the top left corner. And then if you lay the x's side by side, and you fill in the missing gaps with squares, you can build a rectangle. How long was this side here? Do you remember? Don't write that down. Do you remember how long we said that was? X. How long was this side here? Do you remember? X. That's why the area was x squared. You with me? Don't write that down just yet. How long did we say this distance was? Not x. 1. Okay? Let's look at this picture. How long would you say this was? How long is this section right here? X. How long is this section right here? 1. How long is this section right here? So if I hear you, could you, I just heard somebody say it, I think we could say that the length was x plus 2. Yes, 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 yes. Now that you've seen that, how long is the width? I'll give you a hint. X. Jordan.
Plus 4.
Plus 1, 2, 3, 4. Yeah, x plus 4. Mr. Dewick, isn't that actually bigger than x plus 2? Couldn't I call that the length? We're not fussy on which one you call the length and which one you call the width. But I do notice that this is a rectangle that's x plus 2 across the top and x plus 4 high. Part C says, write the area of the rectangle as the product of two binomials. Say what? Area of a rectangle is length times width. If I was to write the area as an equation, I would write it as x plus 2, x plus 4. And Cole, now we've turned this picture into what we actually did last week. We called it FOIL. If you actually were to multiply this out, x plus 2 times x plus 4, Ty, you know what you would get? You would get x squared plus 1, 2, 3, 4, 6 x's plus 1, 2, 3, 4, 5, 6, 7, 8 plus 8. Remember that for a second. We're going to come back to it. Next page over. It says write the polynomial expression that's represented by the tiles below. I'm pretty sure this here is an x squared plus how many x's? 5 x's plus how many ones? 4. And then it says rearrange them in rectangle form. We're not going to do that. We're going to come back to it later. It says use the answers to write it in factored form. We're not going to do that. We're going to come back to it later. Instead, we're going to say turn the page. Example 2, A says, write the polynomial expression that's represented by the following algebra tiles. Careful now. X squared. What did we say if there was nothing inside the tiles, if there was no shading? What did that mean? Negative, nothing, no shading, negative, whatever dumb way you want to remember that. So this is going to be minus, Carmelina, minus how many X's? 2, 3, 4, 5, 6. I think it's 7. 7 X's. You have it in front of you too, right? Or did it show up on your, when I printed it? Yeah. I hope. Okay. Yeah, you can hardly see it behind me. I know. And then, we have a bunch of 1s. These are positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12? Yeah. Plus 12. B says arrange them into a rectangle. We're going to come back to that. Instead, we're going to jump to factoring by inspection. Remember, factoring meant write it as something times something. And what we're looking at today are factoring trinomials. How many terms does a trinomial have? 3. We're going to represent every one of these trinomials. Here is a generic trinomial, x squared plus bx, except, Rachel, there's a number sitting where the b is normally, plus c, except there's a number sitting where the c is normally. You factored them last year. Something like this, x squared plus 5x plus 6. You learned that you could write these as something times something, 2 binomials. Does anybody remember what the trick was to do them in your head? Okay. What you really did is you said, I'm looking for 2 numbers, 2 integers, which have a product of C. When I say the word product, what mathematical operation is that? Adding, subtracting, multiplying, or dividing? Multiply to whatever is sitting where the C is. And a sum, when I say the word sum, what does that mean? Adding, equal to whatever is sitting where the B is. And if you can't find those numbers, it doesn't factor. This example that I made up here, I would look for 2 numbers that multiply to positive 6 and add to positive 5. What are 2 numbers that multiply to positive 6 and add to positive 5? Positive or negative? Positive 2 and positive 3. That told you to put a positive 2 and a positive 3, or a positive 3 and a positive 2. What did you put in front of them? Do you remember? By the way, if you were to make these as tiles, and then you were to build those tiles into a perfect rectangle, you know how high the top would be? X plus 2 across. You know how long the side would be? X plus 3 long. When you're factoring, you're actually building little rectangles too. And that's what this little walkthrough was trying to get you to realize, but I'm cutting corners because I want to get through today's lesson. It says complete the following tables. You do need to know your times tables. You also need to not drop your phones. It's okay. Multiplies to 20, adds to 12. Always start with the times part first because there's way less combinations. What numbers multiply to 20? I'm thinking 1 and 20, 2 and 10, 4 and 5. Which ones of those add to 12? What numbers multiply to 15 and add to 8? What numbers multiply to 18 and add to, careful, negative 9? 6 and 3 add to positive 9. You're very close, though. Kenzie. And negative 3. They both have to be negative so that I can get a negative times a negative multiplies to a positive, but still adds to a negative. Yes. Let's try some with negatives. Hey, let's try this one here, the second one. Multiplies to negative 6, adds to negative 1. I think some combination of 2 and 3. By the way, when this is negative, what you're really saying is I want to find two numbers that are 1 apart. It's going to be a 2 and a 3. One's going to be positive, one's going to be negative. I want the bigger one to be negative because it added to a negative. Negative 3, positive 2. How about let's do the next one. Multiplies to negative 15, adds to positive 2. 5 and negative 3. Now, those of you who haven't really mastered your times tables, I have one word for you. Ouch. Those of you that have, great. Some of you will master them because you're naturally lazy and just start memorizing some of these because you don't have to look stuff up. Factor the following. So, how do we factor? Well, first of all, Logan, what do the instructions here say? The math F word, not the F word you're thinking of? Factor. And when I say factor, what's the first thing that we always, okay, you can cut me off now at any time. I'm going to go until someone cuts me off. Greatest common factor. Is there one here? Is there an X in everything? No, in the first two, but not the... is there a 2 in everything? Well, no, there's a 2 in the 6 and in the 16, but not in the X. Is there a GCF? Say no. No, but I checked. How many terms is there? Is this a trinomial? Yeah. Does it look like something squared plus something x plus or minus something? Yeah. Now, is there something in front of the x squared? That's a trick question. Is there something in front of the x squared? Just an invisible 1. We're going to have to add that question next lesson, because next lesson we're going to say, hey, what if there's something in front of the squared term? Then it gets much nastier, sadly. Then most of you won't be able to do them in your heads. But for now, no GCF trinomial matches the format. I'm looking for two numbers that multiply to negative 16 and add to positive 6. What multiplies to negative 16? 1 and 16? No. 4 and 4. 8 and 2? Oh, that'll work, that'll work. So let's set up our brackets. We know there's an X in the front. There's an X in the front. What were the numbers? I don't think they can be 8 and 2 because that would multiply to a positive. One's got to be negative. I think it's positive 8 and negative 2, isn't it? Because that multiplies to negative 16 but still adds to a positive. Yes? Example 2. X squared plus 5x minus 36. GCF? No. How many terms? 3. Does it match our form from today? Hey, we can factor this by looking for two numbers that multiply to negative 36 and add to positive 5. What numbers multiply to negative 36 and add to positive 5? 9 and 4? Which one where? You're saying a minus 4 and a positive 9 because that would add to positive 5? Sure. What's yucky about number 3? Oh, did we practice rewriting things from biggest degree to smallest degree? Can we rewrite it in our head? Well, heck, let's rewrite it. This is really going to be x squared plus 9x plus 20. You can factor them in that previous form. Why bother? I'm looking for two numbers that multiply. Oh, is this GCF? No. How many terms are there? 3. I'm looking for two numbers that multiply to 20, positive, and add to positive 9. Number 4. I heard it about 5 of you. Ooh, I'm going to show you a shortcut. First of all, let's do our check. GCF? No. How many terms? 3. Is there something in front of the x squared? Nope. So our shortcut will work. Now, how many of you know your 132 times table? Not too many of you. I'm going to give you a hint. We're looking for two numbers that multiply to negative 132 and add to positive 1. What this really means is they're going to be 1 apart from each other. 11 and 12. Now, you would guess on your calculator, I would try dividing by 9. No. I would try dividing by 10. No. I would try dividing by 11. Aha! I probably wouldn't try my 7 times table because, well, maybe. Would I try my 5 times table? No. Did you learn divisibility rules way back in grade 8? There's tricks to telling that 5 goes into it. There's tricks to telling that 2 goes into it, whether 3 goes into it, whether 10 goes into it. Those come in handy. So somebody said the numbers are 11 and 12. Which one's positive? Which one's negative? Number 5. Ah! No. Relax. GCF. Nope. Graham, how many terms? 3. Is there something in front of the x squared term at the very front? Then let's take a guess. Let's hope that if this factors, it'll be 2 brackets. By the way, what's in front of each bracket, Graham? No, even more blatant than that. What appears at the beginning of each bracket so far? You're saying an x squared at the front of the bracket, at the front of the original trinomial puts an x right there, an x right there? Hey, let's take a guess. Graham, if an x squared right here gives me an x there and an x there, what do you think a y squared on the end is going to give me? You're saying a y there and a y there? Sure. We've taken care of the algebra, the variables. All we got to do now is the numbers. I'm looking for numbers that multiply to positive 30 and add to positive 13. Positive 3, positive 10. This factors into x plus 3y, x plus 10y. An x squared at the front gives me an x on the front of each bracket. A y squared at the back gives me a y at the end of each bracket. Mr. Dewick, what about that xy in the middle? Foil this out. Trust me, it'll work. Which, by the way, Tawny, is how you can always check your factoring. So if you finish this test early, this is one test you don't hand in early. What you do is you go back to the factoring section and you multiply everything out to see if it gives you your original question. If it doesn't, you goofed. 3 more, we're done. Number 6. GCF? No. How many terms? 3. You know what? I'm going to guess that this has that. Oh, is there a y squared at the end, Ty? So I think there's going to be a y here and a y here. Is my screen flickering like crazy still? I can't see it behind me, but is it still going haywire? Okay. I've put in an order for a new projector. It's going to take a while to get here. I'm looking for two numbers that multiply to negative 72 and add to positive 71. Don't forget your 1 times table. It's the one we often forget because it's so obvious. It's easy to forget. Mickey said 1 and 72. Which one's 1 and 72? Mickey, I hate putting an... Can I just... There's an invisible 1 right there, please. Which one's positive? Which one's negative? Because I want it to add to positive 72, so I want to subtract 1 from it. You can write the 1. I have no problem with that. You just can't make me. Seven. What do you notice about number 7? Anything weird? I heard 2 things. Cubed, which means this method doesn't work. But I heard from Jordan, hey, there's a GCF. What is the GCF, oh pray tell? I disagree. I heard it here, finally. What? 2x, yes? I can factor out a 2x. If I did that, what would be left behind? An x squared, right? Plus a 5x, with me back there? Psst. Minus 36. Now, from now on, I will expect you, once you factor out a GCF, to glance at what you have left in the brackets, Carmelina, and ask, does that also factor? And it does. Look at what's left inside the brackets. Carmelina, how many terms?
3.
Anything in front of the x squared? Just nothing right in front of the x squared?
1.
So can we try our trick? Are there numbers that multiply to negative 36 and add to positive 5? In fact, if you're really clever, you may have noticed that what's inside the brackets is the same as example 2. Anybody notice that? Yeah, see, I did that on purpose to see who's really paying attention. So if I hear you correctly, this is really going to be a 2x, and then it factored into a positive 9 and a negative 4, yes? How many of you did two-step factoring questions like this last year? A couple of you. When I used to always do this in Math 9, but I would signal my students. The way I would signal my students is on the test, this question will be worth 2 marks, and that told them 2 steps. Not going to do that this year anymore. This year in Math 10, we consider this a 1 marker now. Cole, we figure, you know what? You'll get used to always checking what's inside the brackets to see if it factors further. And if you don't, I'm going to say to you, get used to it. Last one. Example 8. Suggestions? Oh, there's a GCF, because that's the first. Are you cluing in why I said that, by the way? You notice, Jake, if you can factor out a GCF, everything gets smaller and easier to deal with. So I'm going to factor out a 5a squared. And that's going to leave me with another a squared, a plus, a 6a, a minus 10, close bracket. Mr. Dewick, did I make a mistake? I did. I was hoping to make this factor further, and it doesn't. Are there numbers that multiply to negative 10 and add to positive 6? There are? No. You know what, then? That's as far as this goes. By the way, what would factor? What are numbers that multiply to negative 10 and add to? You could have put a 3 here because 5 and 2 would have worked. But a 6 doesn't work. Dewick did some bad math when he was making this example up. We're done here. It won't break down any further. Okay? What's your homework? You need to practice this. Okay, can you all, first of all, look at the first thing that I gave you, which was a take-home quiz. I did my speech to you about how I want to run these, right? I defined for you the difference between learning and cheating. Yes? So this is going to be due. I talked about deadlines earlier in class. This is the only time I give you a firm deadline. This is due at the beginning of next class. But I'm giving you plenty of time in class to get it done here if you want to. Sometimes I won't be able to, but this time I will be able to. Okay? The take-home quiz, because I'm going to start out next class, right at the beginning of class, by yelling at you in love and saying, get out your take-home quiz, let's mark it. Okay? A couple of comments. Please notice on your take-home quiz, there is a back page. It's 3 pages long, grand total. Please notice there is a back page. Okay? 2 questions. I couldn't read. I tried. Anyways, I wanted to give you enough room to write. So it ends with factoring by grouping, not groping, Brendan, grouping. So up to and including last day. Now, put that away temporarily. Take a look at the second sheet that I gave you. How many of you have seen these before? Believe it or not, so have I. My high school teacher was actually giving these to me back when I was in high school in 83 and 84, 1983 and 1984. You know what? They're great because it's a good way to give you the answers without actually giving you the answers. If you get an answer of nif, nif, nah, you know you zigged. And you need to go look at it. This first one, I know you're all dying to find out where does the smell of a skunk go. I think if you write small, you can write right on here. You don't have to. You can do it on a piece of paper if you want to. It's completely up to you. First of all, number one wants you to write out the standard form for the polynomial and then factor it. In other words, they want you to write out for number one that it's x squared plus 5x plus 6 and then factor it. Same with number two, same with number three. Then factor the rest of these. When you find an answer, cross out the letter next to the correct answer, and the answers to the title will remain. If you're not sure how that works, ask me. Take a look at the back page. Number two. Again, I think if you want to, you can write right on the sheet. I think there's enough room if you write fairly small to fit your answers right there. You don't have to. You can if you want to. Go to a separate piece of paper. Here what you're going to do is factor it. Find your answer below the exercise. Write the letter of the exercise in the box that contains the number of the answer. So for example, let's suppose you find that this one is this answer. It's not. You would put in box number 17 an A. And you can find out, of course, because you're dying to know, why is it better to be married to a successful Broadway producer than a plumber? No idea. I'm shutting up. Class, be yours.